Alright, this video is for some math help. If it's been a minute since you've calculated volume or surface area, this is going to be a little bit more helpful. So, I'm writing on a different computer, so hopefully it catches up over there. But when we're looking at the surface area, if we look, I'll draw a little cube here. Okay, the surface area is all of this space that's in contact with the surface. So what that's going to look like with math is we're going to take the area of each of these faces and add them all up. And there are three more that I'm not going to draw arrows to because they're not drawn, but a cube has 6 sides, so there's 6 different sides that have area we would have to calculate. In a cube, that's super easy because all of the dimensions, the length, height, and width, are all the same. So that's pretty nifty for us. This will be an easy one to get started on. So I'm just going to work through this first line with you. If the length is 2 millimeters, let's go ahead and draw that on our cube here. We know that the surface area of one face, so of one side, is going to equal length times width. And in our example here, oops, not sure why that skipped up. In our example here, length and width are both 2, so it's going to equal 2 times 2. And if you need to pull out a calculator for that, that's fine, but it's 4. So that's what you're going to put in, well, actually no, that's not what you're going to put in there. So the surface area of one side is 4, but there are 6 sides. So the total surface area is going to be 4, and we're getting that from up here, times 6, because there are 6 sides. And 4 times 6 is 24. I had to think about that, so if you had to get a calculator out, no judgment. And so 4 times 6 is 24. So the total surface area of cube number 1 in this example is 24 square millimeters. Cool. So now when we're talking about volume, rather than talking about the area on the exterior of the cube, I'm going to move over here a little bit. We're talking about the area contained within the cube. So volume is the amount of space that something takes up. So I'm going to try and draw a diagram that explains that, and it's probably going to look not that great. But can't say I didn't try. So rather than being the exterior, the volume is just the space throughout the entire cube. And volume is fairly easy to calculate. So volume equals the length times the width times the depth. In our cube example, all of those values are going to equal 2. So it's going to be 2 times 2 times 2, and 2 times 2 is 4, times 2 again is going to be 8. So volume is going to be 8 millimeters cubed. And then when we're talking about a ratio, ratios are a little bit tricky. I remember I struggled with ratios way back when I was in middle school, and probably continue to. I remember first learning them in middle school, but I feel like I struggled with them for a while. So a ratio is talking about how much, in this case, how much surface area there is to the amount of volume there is. So let's just do an example, so hopefully it'll make a little bit more sense. But the way you calculate surface area, or the ratio, do it in another color. So I abbreviate this as SA over V. Scroll over so you can see this. And that's easy because that's also how you calculate it. So the surface area was 24. So 24. And we got that from up here. And the volume is 8. (24) divided by 8 is going to equal 3. So in this case, there are 3 times as many units of surface area as there are units of volume. And ratios are a little bit tricky, so just give your brain some time to wrap around that. But that's how you calculate it. And for now, just focus on that. But it's basically telling you when this ratio gets higher, there's more surface area to volume. So there's more surface area. When this ratio gets lower, there's less surface area to volume. So yeah, I don't know. That explanation was not great. I won't lie. Hopefully it makes sense. If you're confused, you can ask us in class and we can help you out with that. But this is just a quick video for the math. If you need more help with the math, let me know. When you get down to these down here, you're going to start seeing different dimensions for the lengths, height, and width. And I guess I'll just do an example since we're here. So in this case, let's do this second line here. So the height is 2, the width is 16. This is not going to be drawn to scale at all. And then the depth is 16. It's a little bit more squished down like this, not quite as cubey as the other one. So height is 2, 16, 16. And the surface area, same idea applies. You are going to be taking the amount of contact that this has with the outside, basically. So you're going to take the area of each of these faces and sum it all up. So let's start with this first face here. Surface area is 2 times 16. That equals 32. Get out a calculator anytime you're not sure. Mental math is hard. I'm going to have to take it out in a minute because I know I don't know what 16 times 16 is. So there's 32, and that's for this side. But remember that on the exact opposite side of this shape, so over on this side, is going to be something with the same dimensions. It's also 2 times 16. So that'll be important in a minute. And if we were to calculate this top shape here, that one is going to be 16 times 16. Like I said, I have to get a calculator out because no one knows that off the top of their head. 16 times 16 is 256. And just like on this face, this top face has one on the bottom too. So this value is going to be doubled. And then as far as these sidebars go, those are also going to be 2 by 16, because this height here is 2, and this is 16. Sorry for the poor drawings. So you're actually going to take this volume, or this area, and it's going to be times 4, because that's how many sides there are that have this value of 32. So 32 times 4 is 128. And then you have to add that to this value over here, and there are 2 faces of this rectangle that have that value, so that one's times 2. So 1 step at a time, 256 times 2 is 512. And then 512 plus the 128 that we calculated a minute ago is going to equal 640. So we're just going to go put that into our table over here. So 640. And the volume, if we need to calculate the volume of this, which it says we do, I used blue for that, so I'll stick with the same colors here. To calculate the volume, I'll just write down, sorry we're going all over here. It's going to be the length times width times height. This calculation is not too much more complicated than with the cube. So that's 32 times 4. Oh man, what did I do? Oh no, never mind. I'm reading the wrong table. That's what. So make sure you put your stuff in the right table. So ignore my previous calculation. Height is 2, width and length are 16, so pull up the calculator again. 16 times 16 times 2 is going to be 512. So 512. And to calculate that ratio, we're just going to take the surface area, which is 640, and divide it by the volume, which is 512. I don't think that was right. 640 divided by 512. It's going to be 1.25. Okay, so that is how you do the math. Hopefully that's helpful.